Welcome back, everyone. So now we'll continue our talk, but introduce amides. Now, if you're in the Timberlake textbook, you're in chapter 18, section 5. In the Libre Tech textbook, you're in chapter 15, section 13. All right, amides. So amides are carboxylic acids with an amine group. And you've covered carboxylic acids with Professor Bradshaw, I believe. Carboxylic acids, this is a 3D structure, but essentially what you have is you have an R group. You have your carbon double bonded to your oxygen, single bonded to an OH group. Amides are pretty much the same thing, except instead of an OH group, you have an NH group, or at least a nitrogen. So you have your R group, you have your carbon, double bonded to oxygen, bonded to NH2. That's your amine. That's the basic structure of an amide. Now you can um, So they're formed by reacting carboxylic acids with amines. That's what replaces the OH group with the NH group. Um, in this reaction, you eliminate water, um, but you can only react primary and secondary amines. And why is that? That's because if we look at this, so we have, well, that's ammonia. Um, but if we look at this, this is a primary amine. So you have two hydrogens to react with. Um, yeah, you have two hydrogens to react with. So you remove one of the hydrogens and you remove the hydrogen, you remove the OH group, and you form a new carbon nitrogen single bond. Um, but you leave the rest of the molecule the same. This is just ammonia. This is basically nitrogen with three hydrogens, but it's the same thing. If you remove the OH, remove one of the hydrogens, you're forming a new carbon nitrogen single bond, and that would be your amide. Um, Secondary amines, you can imagine we have R, C, double bond OH, plus some generic secondary amine um, R, um, R, H, right? Because secondary amines only have one hydrogen. You're removing this OH, you're removing that hydrogen, and then you're forming a new carbon nitrogen double bond with the two R groups. Now, tertiary amines not react because if we look at tertiary amines, let's see, oh, right, secondary here, so we can tell the difference. If we look at tertiary amines, right, tertiary amines have no hydrogens around them, so they have no hydrogen to eliminate or to take away to react with the carboxylic acid. That's why only ammonia and primary and secondary amines can react with carboxylic acids to form amides. When it comes to naming amides, we want to identify the name of the carboxylic acid group, not necessarily the longest carbon chain, just the carboxylic acid group. So in this case, the carboxylic acid, right, is the one with the carbonyl carbon, so the C double bond O, and we have one, two, three carbons. I'm sorry, we have four carbons. That's what yeah, four carbons. That's what affords us the but prefix, and then we add the amide suffix. So butan amide is our base name for right now. And then we want to add an N to denote that there are carbon chains attached to the nitrogen, and then we would name the carbon chain accordingly. So this one has two carbons, so it's N-ethyl butanamide. And then if you had any other substituents, you would name them accordingly. But in this case, this amide would be N-ethyl butanamide.